Hey boys and girls, so today we're going over Unit 1, Lesson 2. Again, just as a reminder, in the top corner you'll see the U1 for Unit 1 and the lesson number is always there. Please make sure you are also writing your name at the top of each page, that way you can get full credit for all the lessons that you are completing. All right, so as I look at the do now, it says, given each of the terms, create two like terms. So I'm just gonna highlight that. The directions are asking me to create two like terms. Now, something we're gonna get in the habit of doing a lot in class is boxing any important keywords that we see. So like terms is a vocab word, so I'm gonna go ahead and just box that quickly. So if I wanna create two like terms, it's telling me that the first one is done already, so let's look there. So it's showing me that the term that I'm starting with is 3x to the fifth. Down below, they're saying that these guys are like terms with that original example. Well, I know that that's true because if you remember from yesterday, like terms have the same variable and the same exponent. So I'm really just looking for an x to the fifth power. I see x to the fifth power. I see x to the fifth power. I know those are like terms. All right, the coefficient, that number in front, it doesn't matter when it comes to like terms. I'm just looking at the variable and the exponent. All right, so as I look at number 2, the only important thing that I need to check is the variable and the exponent. Same thing with number 3. I just need to look at the variables, because there's more than one, and the exponents. I'm going to pause quickly because this has an exponent of 2, right, x squared, but I don't see an exponent on y. I know it's really there, it's just invisible, right, y to the first, so I'm going to add that on. And then number 4, same thing, I'm going to circle my variables and my exponents. All right, so as I look at number 2, I know that I need n to the third in these answers for them to be like terms with the example that they gave me. So I'm going to start off by literally just writing n to the third, n to the third. Now, that vocabulary word we went over yesterday, coefficient, which is the number in front, you can make that whatever you want. I know here they made it a -2. I don't have to make this a negative number. I could, I don't have to. I'm going to make this the number, let's go with 8. And I'm going to make this coefficient, right, that number in front, let me pick 100. All right, so I know that these are like terms with the original example. All right, moving on to number 3. Again, I need x squared, y to the first in both of these for them to be like terms with the original. So I'm going to write that x squared, y to the first, and again, x squared, y to the first. I'm going to switch it up here. Maybe I'll make this a negative coefficient, the number in front. I'll make this a -3. And then on the side, I'll just make this maybe a +4. And then last but not least, same thing. I need the same variables and the same exponents. So I'm going to start off by writing p to the 7th n squared. And then again, for my second term, p to the 7th n squared. All right, I can see that coefficient, the number in front, I'll make that a -1. And then just as practice from yesterday, I don't have to put a number in front here because really there already is a number there if I were to leave it, right? It's an invisible 1. So I can either leave it like this or I could write that invisible 1 in. It's totally up to you. All right, moving on. Underneath, we have some really important vocab to go over. So I'm going to start off by just highlighting definitions because these are the vocab words that we're going to talk about. I'm going to look at the definition of a monomial, a coefficient, a variable, and an exponent. All right, let's jump right in. The definition of a monomial is an expression consisting of, you got it, it's just one term. Maybe you guys can even remember that little section in the front, that prefix, that's in English reference there. So mono means one, so I know a monomial is just one term. Now it's asking, well, what is a term, right? What makes up a term? Well, a term has 3 sections. Let's highlight that. Those 3 sections are a coefficient, a variable, and an exponent. Well, the coefficient we just said is the number in front of the variable. So if I look back at my do now, I see that my coefficient, the number in front of the variable, is 8. So 8 would have been my coefficient for that guy. All right. The variable is going to just be a letter. It's going to be just a letter. Yeah. The base to the exponent is represented as a letter. All right. And then the exponent itself is how many times the variable or how many times the letter is being multiplied by itself. Okay, we'll talk more about what this actual definition means a few lessons from now, but just know that the exponent is that little number in the top corner. All right. Now, if we look underneath, it says label each part of the terms below. I'm going to do the first one, and then I'm going to have you guys practice the next two on your own. So as I look for my coefficient, I know it's the number in front of the variable. So I can see my variable here is x. What's the number in front? It's 6. That means that 6 is my coefficient. Well, what's the variable? I know a variable is just a letter. So I can see that the letter I'm using is x. That means x is my variable. And then the exponent is that little number in the top corner, and it means how many times the variable is being multiplied by itself. So I can see that that little number in the top corner is 2. So I know 2 is my exponent. And again, it just means that I have 2 x's, but we'll talk about that in further lessons. All right, at this point, you should be pausing the video and trying 2 and 3 on your own and then checking back. All right, so if we look at number 2, the coefficient should have been -2. Y is my variable. And this one was a little tough because there was no exponent, but don't forget, right, there really is. It's just invisible. It's a 1. So you had to draw that in. So the exponent was 1. And then last but not least, again, the coefficient, again, it looks like there's no number in front, but there is. It's that invisible 1. So my coefficient was 1. The variable was k. And again, it looks like there was no exponent, but there is. It's invisible, right? It's that number 1 again. So the exponent was also 1. Okay, moving on, flipping to the next page. So at the top of the next page, it talks about adding and subtracting monomials. So that's really the goal of today's lesson. So I'm going to go ahead and just highlight that quickly. If I want to add and subtract monomials, just like yesterday, there's always some steps that we have to follow. All right, here there's 2 steps. I'm just going to go ahead and give those a highlight as well. I can see that the first step tells me to identify like terms, very similar to yesterday. And then after I've identified those like terms, step 2 says to add the coefficients together, and I have to keep the variable and exponent the same. I am not going to change the variable and exponent, they stay the same. So if you remember from yesterday, we were identifying what is like terms, like what makes two guys like terms. Now today, we're going to take those terms, those like terms, and we're going to put them together. And that's called adding and subtracting monomials. So underneath, these are just some rules that you can, memorize. I'm sure a ton of you have a calculator at home on your cell phone, especially if you're coming to school, you'll have a calculator here. So this is only if you really want to push yourself to memorize how to get those answers without the use of a calculator. So if you don't want to use a calculator and you want to add and subtract those monomials, this is what you would do with the coefficients in front, all right? If both signs are the same, which means if they're both a positive, let's say, you're going to add the coefficients, those numbers in front, and you're going to keep the sign. Number 2, if the signs are different, so let's say I have a positive coefficient on one and a negative coefficient on another, instead, you're going to subtract those numbers, and then you're going to keep the sign of the bigger number. All right, so if we look at these examples, I can see here that these are like terms. They both have x to the first. So I'm going to look at the coefficient in front, which is 4 and positive 8. Well, 4 plus 8 is 12. Same sign, I add and keep the sign. So it's a positive 12, x to the first. Example 2. Okay, same thing. I know that these are like terms because they have y to the third on both. So again, I'm looking at the coefficient in front. I have a -3 and I have a -2. Okay, again, both signs are the same. So I add the coefficients. Well, 3 plus 2 is 5. And then I keep the sign. Both negative, it stays negative. And then last but not least, example 3. This coefficient in front is a positive 7. This coefficient in front is a -9. So let's look at step 2. If the signs are different, I subtract the coefficients. Well, what's 9 minus 7? It's 2. And then I have to keep the sign of the bigger number. Well, 9 is definitely bigger and it was negative, so my answer is really a -2. And then again, m to the fourth, m to the fourth. Okay. And again, this is just if you want to memorize the rules without a calculator, feel free to please use one at home if you have it. Okay, examples. It's asking us to simplify each of the following by combining like terms. I'm just going to go ahead and highlight that again. That's the goal of this question. I am combining those like terms. I am adding and subtracting those monomials. I'm going to just do a few with you, and then you're going to practice the rest on your own. This is very similar to yesterday's lesson, so it's just seeing if you really picked up, what we were putting down. So if I look at number 1, first I have to decide if these are like terms. They are. I have b to the 5th, and again, b to the 5th. So I'm going to go ahead and follow these rules up at the top. Whoop. All right. So number 1, I can see that I have a -3 as my coefficient here, and this is a -15 as my coefficient here. Well, now that I've identified that they are like terms, I just combine my coefficients. Well, -3 minus 15, I'm going to say it again, that's how you would type it in the calculator, exactly how you're reading it. -3 minus 15 is -18, and then I just keep the coefficient and the exponent the same. I'm sorry, the variable and the exponent the same. So we have -18b to the 5th. Let's try one more. Let's do number 2. So number 2, first step, are these like terms? Well, yes, they are. X squared, so I'm good to go. So I can see here that my coefficient is a +6. Here, don't forget, it's really an invisible 1. So here my coefficient is really a -1. So now that I've identified those coefficients, I'm going to go ahead and combine them. So in the calculator, I would type 6 minus 1. You would get 5. And then I keep my variable and exponent the same. And that's it. So I need you to just practice the rest of these on your own. At this point, you should be pausing the video and giving those a try, and then check back to make sure that you're getting the same answers as us. Okay, so these are the answers that you should have gotten. If you need to, again, just pause the video, do that so you can just quickly go through and make sure you're getting those same answers that we are. There's only 2 questions I really want to talk about, which are 9 and 13. So number 9, when you combine that -19 with a +20, you get a +1, okay? So you could have wrote 1 f to the 4th, but this really has 2 answers. I could have also just wrote it as f to the 4th, because we keep talking about that invisible 1 that's out front. So I can write it, but I also could just leave it off. All right, so there's 2 answers for 9. And the same thing for 13. If I look at those coefficients in front, well, 5 minus 5 is 0. I get nothing. So I could just write 0. That's a totally acceptable answer. But if you want to keep the habit of including the variables with the exponents, that's correct as well. I could have also said, well, I have no more x to the first, y to the third. All right, but those are the answers that you should have got. Moving on to our final page. All right, if we look up here at the top, again, we have our closure. The closure is for you to complete on your own. It's just to go over a checklist with yourself. You know, did I pick up everything that I was supposed to today? Did I really understand the lesson? And try that question by yourself. All right, at this point, again, please pause the video. Try that one by yourself. Okay. So the question said to simplify the following algebraic expression. Simplify just means, you know, if you have like terms, combine them. And here I do have like terms. I have x to the second, and again, I have x to the second. So I'm gonna keep x to the second in my answer, and then I'm just gonna combine those coefficients in front, which is a -16 and a +4. So when you type that in your calculator, -16 plus 4, you get -12. And then it says, explain how you arrived at your answer. Well, how did I get this answer? I got it by combining like terms. I would just, again, include how you knew those were like terms. When you take the regents, this is how they get you with that word explain. If you do not use some type of vocabulary when you're explaining, you won't get full credit, all right? And then underneath is your homework. That's for you to complete on your own. Make sure you do complete that on your own and show all work in order to earn full credit, all right? And then last but not least, make sure that your name is at the top of each page. There's 3 pages so that way you can get full credit for all your work. All right, awesome. Have a great day, guys.